So today I'll be giving my explanations for question number 2 on the topic paper. So starting off with letter A, use a standard symbol to show a voltmeter connected to measure the potential difference across lamp P. So the standard symbol to represent a voltmeter is a letter V in a circle and across lamp P. So this is lamp P, and so we draw the voltmeter across surrounding lamp P. Letter B, record the current I in the circuit. So basically they're telling us to just read the reading in figure 4.2. And so this is 0.3 between 0.2 and 0.4. And so this is 0.22, 0.24. And it's right in the middle of those two numbers. So the answer is 0.23. Continuing on with letter C. They're telling us to do the same thing as letter B and to read the readings in this figure. And so for lamp P, this is 2.5, then this will be 2.6, 2.7. And for lamp Q, this is 0.5, so this will be 0.1, 0.2, and 0.3. And therefore, we write the numbers in the table. Lamp P 2.7, lamp Q 0.3. Continuing on with the first part of letter D. A student thinks that lamp Q is not glowing, its filament must have broken. And so the answer to this is lamp Q's filament is not entirely broken, as there is still some current left in the circuit, which you said was 0.3 volts earlier. It is just not as bright as lamp P. For the second part, they're saying that the lamp to be at its full brightness is 2.5 volts. And so they're telling us to explain the observations of the brightness of the lamps. So for lamp P, it is 0.2 volts greater than the full brightness, which was 2.7. And this means that this lamp is near the working voltage and is at its full brightness. However, on the other hand, lamp Q is much less than the working voltage by 2.2 volts, and so this therefore means that lamp P is very bright, while lamp Q is not glowing based on the potential difference. Letter E, they're telling us to calculate the total resistance R, and so they already gave us the equation here, so we just need to plug in the numbers. So VP was 2.7, VQ was 0.3, and the I was 0.23. So at this time, we're bringing our calculator. And so 2.7 plus 0.3 is 3. And we divide it by 0.23. And so the answer is 13.0434, etc. But these numbers here are all in 2 sig figs, so we round to 2 sig figs. And so the answer is 13. Last but not least, letter F. So a student measures the potential difference Vs across the power supply to be 3.1 volts. And so this student suggests that Vs should be equal to Vp plus Vq. And so the statement here is that Vs should be equal to Vp plus Vq. And the justification for this is that although Vp plus Vq was 3.0 volts and not 3.1 volts, it is still within the limit of experimental accuracy, and therefore the student's suggestion is supported with evidence. Thank you.